Welcome everyone to Friday Office Hours. It's actually the first Friday Office Hours of the new year, so we're really excited you're here today. My name is Anna Shavers, and I'm the Senior Communications Specialist at the All of Us Data and Research Center. Before I introduce our speaker today, I do have a couple announcements I want to share. First, as I mentioned before starting the meeting, we are recording this session. The recording will be posted within about 1 to 2 weeks on our User Support Hub and on our YouTube channel, so you can kind of go back and reference that if you need. Next, the Delta Research and Educational Foundation is hosting Practical Strategies to Conquer Obstacles in the All of Us Researcher Workbench on January 23rd from 12 to 1:30 p.m. Eastern Time. This session does provide an invaluable opportunity to enhance your skills in navigating the Researcher Workbench by offering actionable strategies to overcome obstacles. It's led by experienced facilitators. The session will include insights, best practices, and lessons learned from working with diverse data sets and tools. So if you're interested, scan the QR code here to the right to register. Note, because this presentation or this educational opportunity is happening next week, registration is due by January 21st, which is Tuesday. So make sure to get that in. Last but not least, we do have Baylor College of Medicine's 2025 Biomedical Researcher Faculty Summit application is live. I think we've had this one a couple times in office hours, but of course, as we get closer to the deadline, want to make sure that everyone has the opportunity. So the All of Us Evenings with Genetics Research Programs Biomedical Researcher Faculty Summit is designed to train early career researchers to access and utilize the All of Us Researcher Workbench. The 2025 summit is going to be held May 14th through the 17th in Houston, Texas. And if you're interested, you can scan the QR code to the right and apply by February 28th. So that's all actually the announcements I have for today. So we'll go ahead and get our presentation started with an introduction of our speaker today. We're really excited to have Elif join us from the National Institute on Minority Health and Health Disparities. Elif is a data scientist at the National Institute on Minority Health and Health Disparities, where she collaborates with the Science Collaborative for Health Disparities and Artificial Intelligence Bias Reduction Thinkathon research teams, and works on enhancing platform and data usability for researchers with diverse skill sets. Elif holds a bachelor's degree in computer science from Auburn University and completed her Ph.D. in human development and family science at Syracuse University, where she also earned master's degrees in applied statistics and child and family studies. She completed her postdoctoral fellowship at the University of Missouri-Columbia. Prior to joining the NIH, she was an assistant professor at Auburn University, taught graduate courses in statistics and research methods, and served as a statistical consultant supporting national and federally funded projects. Her research interests include spatial patterns of neighborhood risk and resources, parenting and its impact on child outcomes, the efficacy of couple relationship education programs, and the influence of socioeconomic factors on health and development. She is also a carpentries instructor, teaches data and software carpentry workshops, and maintains the R Ecology Data Carpentry Repository. We're so excited you're here, Elif, to talk with us about simplifying the preparation of all of us survey data with the omop2survey package. And with that, I will hand it over to you.
Thank you so much for the introduction. Let me share my screen. Okay. Let's start. Okay. Hi, everyone. Thank you for joining us today. So, as you heard, I'm actually happy to be here to finally introduce this package to you and also show you how to use the package in Python and R. So, just a quick background. So the omop2survey package is a Python package that you can install from Python package directory, or you can also install directly from the GitHub. I created a GitHub repository, and that's open access. It has all the codes, and it has like some examples that shows you actually what's in the the workspace right now, also in the GitHub package. You can find like the R and Python tutorial. So this package actually simplifies the data cleaning process to facilitate the transformation of AU survey data from like the long format, the omop format, to wide format. And it just aims to simplify the process. And it also has functionality to generate the codebook, like creating scale scores, also creating like indicator variables, dummy coded variables. And you can save like everything in a CSV file format to bucket. So actually, there are not many packages related to all of us. I know there are some effort using R, but this is just an example of like how targeted software solution can transform data management for research, because there's a gap between how data is collected, stored, and analyzed. And I believe this package just provides a bridge between the complex data collection method, storage method, and the data analysis processes. Okay, so I actually developed this package as for one of my coursework. As Anna mentioned, I was a faculty at Auburn University, and I was using AOE data. And I worked with students, collaborated with other researchers. Later, I worked as a data scientist at the All of Us program. As everyone knows, the data set required quite a time for cleaning and processing. So making data analysis ready is a long and time-consuming process. And it's challenging for many researchers, regardless of like their experience level, because many are not proficient in programming languages, or they're not familiar with the structure, how all of us data store, like omop data model. And cloud computing is also challenging for researchers. There are also training opportunities, but it might not be accessible for everybody, or people may not have time. So I believe these challenges require like some structured approach to how we are going to like clean and analyze data. About my cat. So my goal was to like reduce the amount of time we spend data cleaning and making data analysis ready, and also like to minimize the errors and make data available to like the many researchers. Okay. Now I'll overview the functions in the package and show you how to use it. So here, I created a workspace for this package demonstration. I included the Python code, Jupyter Notebook, and I am adding also like the R tutorial, and I will publish the workspace as a community workspace in a couple of days. And in that workspace, you can find those demonstration notebooks. So the notebook is step-by-step process that shows you what you need to do to prepare data. And actually, in 10 minutes, regardless of what type of survey you are using this package, you can prepare your data and start your analysis.
Hey, Elif, are you sharing your workspace on your screen? If so, I can't see
No.
it. I'm not. Oh, okay.
I'm not sharing.
Perfect. Okay.
Am I allowed to share?
As long as it doesn't have participant level data, you can. But I just was making sure you weren't sharing your notebook and we were supposed to see it.
Yeah, there are some like the data in it, so I didn't want to share it. This is just the slides. Okay, in the notebook, like there are 5 steps required for you to collect clean data and make the data ready. And there are also like the additional steps you can utilize to transform your data. Like those steps, starting from like the installing the package then reading data. There are two ways you can read data. And then that the functions in the package in the third step convert data, all the OMOP codes to numeric values or the text values, generate codebook, and then convert data format. So let's start from the first step. Okay. So the first step is, again, for all of the Python analysis, I believe that's this. You start from installing the package. If it's not built-in functions you are using, then import all the packages. So you can install the package using pip, and again, the package name is omop2survey, and you need to import package using import function. And there are other packages I add. These are not required for the omop2survey package utilization, any of the functions, but I included those. If you are using SQL to read data, you need to import those packages anyway. Okay, after installing and importing those packages, next step is reading data. So you have two options to read data. The first option is the traditional option. So you can use SQL. You can either use tools in the Workbench, copy paste the code, and then read your data. That's the options you are familiar with. Or you can use the function in the package, which is show survey options. So this package, what it does, it lists all the available surveys, and then it shows you how you can use this function. So regardless of the data version, right now I believe it's 7, the version 7, and then regardless of the AU data release, you will see all the surveys, and then you will see the index. So this is just a simple way to import all the surveys using this function. But the one thing is, if you are using show survey options in the package, you are importing all the variables in particular survey. So this is the first step of reading data. First, you need to use the show survey options. And then in the next step, you need to use the function import survey data. How you are going to use it? So looking at the index and the survey names, you just need to put one number inside the import survey data function. Then when you run the function, it shows you what query it used and what is the survey name and number of unique person ID in the data sets. It also shows you the data, but I didn't include here. But you can see the names of the variables in the selected data set. Okay. That's about reading data. That's the second step. Then we can move to the third step, which is converting answer concept IDs to numeric values. As OMOP data format uses different labels for each answer, so we need to transform all the answer concept IDs to numeric or the text values so we can analyze it. So again, you have two options. You can either use map answers function. So how you are going to utilize this function? After map answers, you need to put the dataset name inside the function, and that converts all the variables inside that dataset to numeric values and text values. I'm going to show you actually how the data looks like later. So this is the one option. If you have small data sets, like small sample size, you can use map answers function. It's fast enough. But if you have large data sets, there's another function, which is process answers. It does the same thing. It converts all the variables, answer concept IDs, to numeric and text values. But this function is kind of optimized. It uses parallel processing and all available CPUs in your environment, and it processes map answers faster. So for a data set, I tried both functions using different sample sizes. In one data set with more than 1 million rows and 5 columns, it took 47 seconds to transform all the variables to numeric and text values. And the same data set took almost 8 seconds with their process answers functions. Let's move to the next step. Next step is generating codebook. So now you read the data, transform all the variables, and now we can look at how data were transformed, and we can have a document that will show us the codebook of the data. So the function is codebook. We just need to put the dataset name inside. It shows you the link where the codebook was saved. You can go back to that link and download the codebook later again. And it also shows you the structure of the codebook. As you can see, these are the original concept IDs, question concept IDs, questions here, answer concept IDs. And then there are additional, like the 2 column here, answer concept ID recorded as answer numeric. That's a variable map answer function creates. And you can see how each answer were mapped to numeric values. And you will see the text value of the answer. And there's another column variable that map answers function creates. It's the same value, but some of the answers were shorter, like there's no PMI, there's no variable name in the answers text variable. So that's the codebook. You can use it and you can download it and save to it saves your workspace anyway, but you can utilize it later too.
Could I ask a question about that?
Yes.
That's really a nice function to have the package convert from text to numerical responses. What happens if some of the questions have written word responses that aren't on the scale of none of the time to all of the time? Like, do any of the questions have responses like strong disagree, agree, strongly agree? And if so, how does the package know to convert those types of responses?
Yeah, actually, like this is just the one example. One question you will see how answers were recoded, but the package has all the survey variables, all the answers, and the meaning. So whatever you are using, it will show you the exact correct answers, regardless of the scale.
I see.
Yeah.
Oh, that's very helpful. Thank you for doing that.
And let's move to the next slide. Okay, after generating codebook, the next step is converting data from long to wide format. Because omop data, the common data model, actually stuck all the variables data sets, right, in a long format. And if you are using like some time series specific analysis, long format is really helpful, or for the descriptives too, you can use long format data. But if you are using like the other type of statistical analysis, you need wide format data. So like the long format has all the questions in one column, but the wide format, all individuals have one row and there are several columns, several variables for each question. So that's a typical, actually, data format we use in any type of like the statistical analysis. So there are two functions. One is pivot, and then the other one is pivot text. So if you are using pivot, that use the numeric values to convert data sets. And if you are using text, that uses text values to convert the data set. And then it saves the data set to your workspace bucket, and it shows you the link where it was saved and how it was labeled. So by default, the converted data set was saved as for the numeric values, pivot_n. And then for the text, if the function is using the text values, it's pivot_t. But if you put name inside the function, as you can see, input data and then the output, if you define the output name, you will change the dataset name. If you put like the output.csv, data will be saved as output.csv. If you put, say, like the survey data here, .csv, it will be saved as survey data CSV. That's what's the next step. Okay, these were all the required steps. So read data, map answers, generate codebook, and convert data set from long to wide format. So your data is actually ready. But there are additional functions in there you can utilize. One of them is recoding all the missing values, because there are several different missingness in the all of us data sets, which I believe is very helpful to define and look at like some of the relationships. But you need to recode all of them. You need to actually define as missing all of them to be able to analyze the data. So this function knows all the missing values in the all of us survey data sets, and it converts all of them to pandas NaN value, which is missing value, and then keeps the other values as this. So you will see in the sample DF dataset as a numeric, which is the variable was created using the map answers function. You will see one missing value here is -998. But when you recode the data set, that value will be NA. Another function is create dummies, dummy coded variable, indicator variable, or binary variable. You can create using this function. So one of the function, it's not here, but the package has a function that reads all the variables with multiple answers, right? So like the race variable, race ethnicity variable, it could be like the more than one category might be selected. So create dummies, what it does, takes all of the categories, regardless of whether it was selected once or it was selected like the other more than one category. It creates binary variable for each category in one variable. And you will see here the it uses question concept ID, right? You are using long data set. If you are using long data set, it creates like the several variables. And if you are using wide data set, it's again create like the several binary variables. You will see, let's look at one variable here. So the first variable, right, ends with 39. When you use create dummies function and you put the dataset name in it, so the resulting dataset, it has the same variable here, but then again, let's see. So this variable is not, it doesn't have like the multiple choice, but the last variable here has select more than one category option. So you will see the variable itself here, but you will see additional variables created for this variable. So the first one is question concept ID, and then the second part of the variable is the answer concept ID, you will see. And all of them are just the binary variables were added to your data set. So the last optional step is calculating scale scores. For this function, there are more than, you need to code a little bit, actually. But what you need to code, you need to define the variable names. You need to define a scale name because you are creating a scale. And then, of course, you need to define the dataset name. So scale is the function name. You put first dataset, then all the variables you selected, and you put the scale name. So it shows you the minimum maximum score calculated and number of cases, missing cases, and number of people, participants whose score were calculated. So in this function, actually, there are some options you can specify. So if you are going to include, if you want to include missingness when you calculate the scale score, you can define NA equals true after the scale name. You can put that option. Then what it does, it calculates the scale score for all rows with at least 80% of information. So it tolerates up to 20% of missingness. But by default, it's false. There's also another option. You can either use sum or composite. So like you can create two types of scale score using the average of all the variables, or you can calculate using the sum of all the values. And that's what package does. And if you are following those steps, like under 10 minutes, you can make your data ready for analysis. Okay, now I'm going to show you how you can use the package in R. So you cannot use Jupyter Notebook with R kernel. You need to use RStudio, that's for this package. Because actually, what you are going to do if you are using this package in R, you will still use the Python functions, but there's a specific R library that will let you use the Python packages. Okay, structure of the notebook. our script is very similar. But the important thing you need to pay attention is how you are going to install packages, because you need to define a virtual environment to be able to utilize this package in RStudio. You can use R script or R Markdown, it doesn't really matter. But the first thing, you need to install this package. I believe that's reticulate. I'm not really sure how to read it. First, you need to install this package. Then you need to import package using library function. Then you need to create a virtual environment. That package allows you to create a virtual environment where you can use Python in this environment. So you will define the virtual environment, and then you need to tell program to use virtual environment, not to build in the Python program. And the third step is using this virtual environment, install omop2survey package in RStudio. That's the setup. After you set up your virtual environment, how you are going to use the package is very similar. So in Python, how you are using the package, first you put the name or the initials, how you import the package name. Then you put one dot, then the function name. So in R, instead of dot, you use the $sign. So let's see, I imported dataset using my initials, but in the workspace, you will see omop. After installing the package, importing the omop2survey, then, okay, that's the first step, is the same step. How you are going to use the function. So this is how we imported the package, edy, then the $sign, then the function name. So it's not different than how you are going to use in Python. All the functions work in RStudio, but RStudio's processing time is a little bit slower. The RStudio in general, a little bit slower because the data set is very large. And how you read data, again, the package name, $sign, then import survey data. That's the second step. So in R, instead of map answers, it was the function in Python. You need to use map questions because of the data structure, how R reads it, it's a little bit different. So I define a different variable to map all the answer concept IDs to numeric and text values. But that's, again, one function, map questions. And if you have like the large data set, and if you want to process map answers, you need to use process answers function. It's again the same. Then how you are going to generate codebook, it's the codebook function in RStudio. Then the rest of the functions are actually the same. There's no difference. You can use pivot and pivot text. Then recode function, create dummies, and scale. So before concluding, I would like to actually thank Rami, Thomas, and Ellen. I think Ellen was here, but maybe he left. So they supported this function, this package overall, and kind of helped me to finish the package. And I would like to acknowledge their help. Now I can stop sharing and answer questions if you have any questions.